Okay, so hi everyone. So welcome back to the fourth video in this playlist. So today in this video we are going to solve this problem from CSES problem set that comes under the tree algorithms part and goes by the name tree distances 1. So before starting this video, if you are new to this channel and have not yet subscribed it, then I will suggest you to subscribe this channel as there is a lot of amazing and important content related to competitive programming topics already uploaded on this channel. So yeah, if you have not yet subscribed it, consider subscribing it and share with your friends who need to watch these videos, right? Okay, so let us get back to our problem now. So the problem reads like this, that you're given a tree consisting of a total n nodes and your task is simple. So your task is to determine for each node the maximum distance to another node. So here we are given a total of n nodes in a tree, right? So we are given with a tree consisting of n nodes, and for each node from 1 to n present in that tree, we have to find the maximum possible distance from that each node to any other node present in that same tree, right? So in the input, the first input line contains an integer n, and this will represent the total number of nodes present in the tree, and the nodes are numbered from 1, so 1 to n. And after that there are n minus 1 lines describing the edges. So each line contains two integers a and b, that is a bidirectional edge present between nodes a and b. So using this input the tree will be constructed, right? And in the output we have to print a total of n integers for each node from 1 to n, representing the maximum distance from this each node to any other node in the tree. So these are the constraints in which n can go up till 2 into 10 to the power 5 and a and b can go up till this n. So this is a given input here and this is the expected output. So this is the overall question. I hope you got the question. It is not that much hard to interpret it. So without wasting any further time, let us go to the blackboard and try to understand what logic we will apply. And also let me tell you one thing, that if you have not yet watched the previous video, that is tree diameter, that I have uploaded today, then I will recommend you to watch that video first and then only come back to this video, because this question will utilize the concept of tree diameter that we have learned to found in the previous video, right? So yes, if you have not yet watched it, please go back and watch that video and then only come back to this video. So let us go to the blackboard now and try to understand how we will use the tree diameter concept in this problem. So if you remember, then in our previous lecture we were finding the diameter of this tree only, and we came to the conclusion that the diameter of this tree was equal to 9, and it was present between this 16 and this 5, or between this 16 and this 7, because the distance between this 16 and 5 is the same as the distance between this 16 and 7, which was equal to 9. So I can say that the diameter of this tree was 9, and we were able to find a solution to this problem in our last lecture, right? So now we want to utilize the same diameter concept here in order to calculate the distance of each and every node to the farthest node possible, right? So let me clarify the problem requirement here. So suppose I'm standing at the second node. So if I'm standing at the second node, then I want to find the distance between this second node and any other node in the same tree, which will have a maximum distance with this second node, right? So the distance of this second node is 2 for this 10th node, right? Because it will consist of this path. Also the distance of this second node from this 17th node will consist of this path, right? Which will be equal to 4. And similarly, the distance between this second node and this 16th node will consist of this path here, which will be equal to 5. And this will be maximum. Also the distance between second and 5th node here will consist of this path, which will be equal to 4, right? So since the maximum distance from this second node to any another node in this tree is equal to 5, which is with this 16th node, that is this path, so for the second node we will print this distance only, that is 5. So we will print 5 for the second node, and the same thing you have to perform for each and every node in the tree. So this is the question here now, and now we have to think how we will solve it using this diameter concept. So if you remember, then in the previous problem we found the diameter by utilizing these two arrays, right? So this was our very first array in which we calculated the distance from the root to each and every other node present in the tree, right? And also when we did this, then we were able to derive this node, that is the first farthest node. And once we derived this first farthest node, then we ran a second DFS call, and using that second DFS call, we calculated the distance from this first farthest node to each and every other node present in the tree, right? So you remember this, and using this second DFS call only, we were able to locate this second farthest node and the distance to it. So using that logic, now we have the information of the diameter of this tree and the extreme end points of this diameter. That is, now we know the end points of this diameter, that is this 16 as well as this 5 now. So now if we know this 16 as well as this 5, how can we use this information in order to solve this problem? Because this question is asking us to find the farthest distance for each and every node. So I want you to pause this video and think for a moment that for each node, what will be that maximum distance? So I hope that you pause the video and try to think. But if you are not able to think, then let me tell you the crux here. So the crux is that for each and every node present in this tree, the maximum distance for that node will either be going till this first farthest node or either be going till this second farthest node. So if I'm standing on this second node, then the farthest distance between this second node to any another node in the tree will either consist of this path or either consist of this path. So we have to take the maximum of both of them. And this is obvious also using common sense, right? Because why would anyone try to find the distance between this 2 and this 10 when we know that this 16 and this 5 are the extreme corner points of this tree, right? So if this 16 and this 5 are the extreme corner points of this tree, then obviously the distance between this 2 and this 16 will either be maximum, or distance between this 2 or either this 5 will be maximum, right? So we should not consider any other internal or leaf node. So we just have to look at the extreme end points of this diameter. And even if you don't believe me, then let me make you visualize the same thing by flattening this tree into a straight line, right? So let me quickly do that for you. So you can see that I have flattened this tree into this, right? And I have done this so that you can visualize the distances better. So this was our first farthest node, which is present here right now, and this was our second farthest node, which is present here now, right? And the original diameter was 9. So this is the diameter of this tree, and if you calculate the distance here, so 1 2 3 4 5 6 7 8 and 9. So this is the diameter of the tree, having a diameter of 9, right? Now I told you before that in order to calculate the distance for each node of this tree to any another node and to maximize that distance, we have to go to the corners, right? So suppose we want to find the maximum distance starting from the second node to any another node in this tree, then obviously we will not be dealing with the internal nodes, right? We will only be dealing with the extreme corner points. So either we will go to this 16, or either we will go to this 17, or this 10, or this 8, or this 18, or this 7, or this 5, right? So out of them only we will get the maximum distance from this 2. And the same thing we will be doing for all the nodes. So even if you are standing at this 14, then the maximum distance starting from this 14 will go either to this 16 or to this 17 or to this 18 or to this 10 or this 8 or this 7 or this 5, right? Because they were the leaf nodes, right? So out of them only we will get the maximum distance for each node. So now, since we know that this 16 and this 5 are the extreme corner points of this tree, so I can say that these two nodes are the most far apart nodes present in this tree, right? Because they are the maximum stretched nodes present in this tree. They are very much stretched. So if you want to find the distance for any node here, then out of all the possible leaf nodes that I just told, these two extreme corner points will be the best candidate. That is, the maximum distance between these two and this 16 will be either maximum, or the distance between this 2 and this 5 will either be maximum. And you don't have to look out any other leaf node, right? Because it is clearly visible in this diagram. These two are the only possible leaf nodes for which we should check the distance and take the maximum for both of them, and we don't have to check out any another leaf node. So here as you can see that the distance between 2 and 16 is what? So it is equal to 1, 2, 3, 4, 5. So 5 and what? So 5 and 1, 2, 3, 4. So 5 and 4. So what is the max of 5 and 4? So it is equal to 5. So I can say that the maximum distance starting from this 2 is nothing but 5, which is till this 16th node, like this. And the same thing can be done for each and every node. So suppose I want to find the maximum distance starting from this 15th node. So if I want that, so instead of looking at any another leaf node, what I will do is I will cleverly look at only the extreme end points of the diameter, because they are the most far apart in this whole tree. And that is why the distance from these end points to any another node will be maximum, right? So the distance between this 15 and 16 will be equal to 1, 2, 3, 4, 5 and 6. So 6 comma 1, 2, 3, 4, 5, 6 and 7. So 7. So 6 comma 7, that is the max of both of them, which is equal to 7. So I can say that the maximum distance starting from this 15 that we can travel in this tree is 7, and that will be this path, that is between 15 and 5. That is between 15 and this 5. So we just have to take the maximum distance starting from the current node to this endpoint and from this current node to this second endpoint. And by taking the maximum for both of them, we will get the maximum distance that we can travel in this tree starting from the current node, right? So I hope you got this. This is the core concept here. So how we will do this now? Since we earlier calculated these two arrays, so this array was solely used to calculate the value of the first farthest node, right? And nothing else. So once we calculated the first farthest node, we ran a second DFS call so that we were able to find the distances between this first farthest node to every another node, right? So using this second DFS call, we have calculated the distance between this first farthest node to each and every another node present in this tree, right? And now what I'm telling you to do is, since we want the maximum distance for each and every node to these extreme corner points, so we should have the knowledge of the distances for each node to both of these endpoints. So if someone asks you to give the distance between this 11 and this 16, then you should report it immediately. Similarly, if someone asks you to report the distance between this 11 and this 5, then you should report it immediately. Or you can imagine it like the distance between 11 and 16 is the same as distance between 16 and 11. And also the distance between this 11 and 5 is the same as distance between 5 and 11. Right, so that's why if you calculate the distance from this first farthest node to each and every another node in the tree, then if someone asks you to give the distance from any another node to this first farthest node, then you can simply use this array in order to give that answer. The same thing will be done for this extreme point. So if you calculate another array now, which will hold the distances from the second farthest node to each and every another node in the tree, then if someone asks you to give the distance between 15 and 5, then you will simply report the distance present in this third array between, which is holding the values of distances between the second farthest node and each and every node present in this tree. So I will do the same thing here now. So since this was our array here, right? So we will use this array and also we will construct another array, right? And this time I can say that the distance will be measured from the second farthest node. And so by doing that, to do that I have to erase this information because this is for the first farthest node. Now since I want to fill this, so see what is the distance between the second farthest node to this one. So it is equal to 1, 2 and 3. So I will just write a 3 here, right? Now what is the distance between this second farthest node and this 2? So distance till 1 plus 1, that is 3 plus 1, that is 4. So it will be 4. Now what is the distance between 5 and 3? So it is 2. What is the distance between 5 and 4? It is 1. What is the distance between 5 and 5? So it is 0 only. What is the distance between 5 and 6? So 1, 2, 3. What is the distance between 5 and 7? So 1, 2, 3, 4. What is the distance between 5 and 8? So 1, 2, 3, 4, 5. What is the distance between 5 and 9? So 1, 2, 3, 4, 5. What is the distance between 5 and 10? So distance till 9 plus 1, that is 6. What is the distance till 11? So the same as 10, that is 6. And the distance till 12 is what? So same as 10 and 11, that is 6 only. What is the distance till 13? So 12 plus 1, that is 7. And what is the distance till 14? So 13 plus 1, that is 7 plus 1, that is 8. And what is the distance till 15? So distance till 11 plus 1, that is 6 plus 1, that is 7. And what is the distance till 16? So the distance till 16 will be 9, because this is the diameter, if you remember, right? So 14 plus 1, that is 8 plus 1, that is 9. And what is the distance till 17? So it is equal to 13 plus 1, that is 7 plus 1, that is 8. And finally, what is the distance till 18? So it is equal to 15 plus 1, that is 7 plus 1, that is 8. So in this way, I have calculated the distance from the second farthest node to each and every another node present in this tree. And once I have these two arrays now if someone asks you to find the farthest distance for this 11th node to any another node in the tree, then we know that either it will go to this farthest node, first farthest node, or either it will go to the second farthest node. So we just have to take the maximum of them. So here if you see, then the distance between this 16th, that is the first farthest node, and this 11 is what? So it is equal to 5. And what is the distance between this second farthest node and this 11? So if you look in this array, then for the 11th index it is equal to 6. So it means that the distance between the second farthest node and this 11 is 6. So if you just take the maximum of it, then it will be equal to 6. So I can say that the farthest distance that I can travel if I start from this 11th node will be equal to 6. So 1, 2, 3, 4, 5, 6. And you can try on your own and you will realize that this is the maximum distance that you can travel in this tree if you start from this 11th node. And the same thing will be done for each and every node, right? So if I write the answer here for each and every node, since we have to print it for each and every node only, then I can say that for the first node, the farthest distance will be the maximum of 6 and 3, that is 6 only. So let me write it here, 6. For the second node, it will be maximum of 5 and 4, so 5. And the same thing will be done for each and every node. So let me write it quickly. So this will be the answer required here, and we just have to print. So I hope you got everything that I have told in this video, right? So without wasting any further time, let's go to the coding part now and quickly code this up. So let us go to the code editor now. So if you remember, then this was our code for the last video in which we tried to find the diameter, right? So this was our diameter. So once we have found the diameter, so we don't need to print it now, and we know that this diameter is stored in this maxi variable, right? But this time we need to find the second farthest node, right? So we need to find the second farthest node. So I have initialized the second farthest node to -1 now. So we know that if this distance of I is greater than maxi, then we will set maxi like this, and I will say that this second farthest node will be equal to this I now. And once it ends, we will have the information of both, that is the first farthest node as well as the second farthest node. So once this second farthest node is calculated, we know what we have to do. We have to run a DFS call starting from the second farthest node, right? So that's why I will run a third DFS here, and its parent will be -1. And after it returns, our distance array will be updated again. But now I have to make sure that this distance array is different from the previous one. So what I will now do is, I will say that vector LL distance from, let's say, first. So it is equal to this dis now. So I am storing this information so that the information is not lost. And once this DFS call returns, I will again have this distance array, and that distance array will be holding the information for this second farthest node, right? So I can say that distance from second will be equal to this distance now, right? So once it is done, I just have to print for each node from 1 to n here the maximum of distance from first, right? So it will be cout. So max of this I, comma, distance from second of I, right? So and also don't forget to give a space like this and finally return. So I think this will be our logic here. So let's see if it is giving the correct answer or not. I think I did a small mistake here. So since we are running this DFS again and the distance array will be used again, so it means that I have to reassign it with zeros like this, right? So now if I run again, let's see. So as you can see that the test case is getting passed here and our answer is correct, right? So let me try to submit this same code on the platform right now so that you can uh, believe that our solution is correct. I hope this gets accepted. So as you can see that our solution is accepted finally, right? So thank you so much for watching this video. Thank you.